All right, here's a quick tutorial on how to start the electric Evo. First things first, there's two keys. This key right here with the triple silver diamond star is the original key with the vehicle, so it operates all the doors and the trunk. This key right here is unique to this ignition assembly, which I did have to replace during the rebuild process. So to start the vehicle, we're going to go down here to our little switches, turn on the 12-volt system. This gauge will come on to let you know that we're currently operating at 12.44 volts. And if I go over one, it's telling me 5 amps. That's really high. It should drop down about half an amp just to run that 12-volt contactor. The next step we're going to do is we're going to put in the key to the ignition, and we're going to turn it to the on position, but do not turn it to start. There's no starter in this vehicle. And when you do that, you'll see some movement in the gauges. I'll just go back and show you. So the gauges do a little dance, and then the odometer comes on, shows 915 miles, and then I've got a trip meter there, which does take a few minutes, well, about a minute to upload because it relies on GPS. After you've got the 12-volt power on and the key turned, come down here to this switch. This closes the main contactor for the high voltage circuit, which supplies power to the motor. So you're going to flick this and wait to hear a click in the engine bay. There's our click. In very cold and very hot weather, it can take up to 1 minute for that click to happen. But once that click happens, you know the contactor's closed and you have power to the motor. So we're going to throw it neutral here and just give it a quick rev. So we've got power to the motor. This switch right here is for the water pump. There is no coolant in the coolant system because I never ran the motor that hard. So just ignore that. This tablet right here, if you hit the on switch, give it a swipe. This is the torque app, which is located right here, that icon. Go to real-time information. This pulls up your pack voltage, your current draw on the battery pack, your amps, your highest voltage cell, and your lowest voltage cell. At about fresh charge, this pack has about 192 volts. It is not in great condition. It's old, and it's one of the first gen Nissan Leaf packs, which did not age very gracefully. So right now, it's about 192 volts right off the charger. It should be really at about 200 volts, but it's just an old pack. So to drive the vehicle, the clutch pedal is really an on-off switch. So to press the clutch, select your gear, put it in reverse, come off the clutch. We're at 0 RPM, but that's okay. It's an electric motor, and we'll just hit the accelerator. And away we go. Clutch in, first gear, off the clutch. We're just sitting here at 0 RPMs, and then accelerator forward, and there we go. And then to stop the vehicle, shut it down, we open the high voltage contactor first, down with the switch, key out, and then 12-volt system off. And then, like any other manual ICE car, I do keep it in gear when it's parked with the e-brake on. And this e-brake is awesome. It's got a lot of grip. This is a quick video on how to turn off high voltage power in the engine bay if you want to work there. So you come back here, we've got a high amp fuse. I think it's 1,000 amps. And this is a master disconnect switch. Turn that to off, and now this kills high voltage in the engine bay. Of course, there is a high voltage contactor in the engine bay that closes when you hit this switch. So if this switch is off, you should have no voltage in the engine bay. But just as a precaution, I turn off that switch in the trunk as well. So I showed you how to make the engine bay safe for any kind of maintenance or work or stripping, whatever you need to do. Once you do open that switch in the trunk, that should turn off voltage to this motor controller here. The motor controller takes the battery voltage and sends it to the motor. What I would do before working in the engine bay is to take a voltmeter and just check each one of these connections. There's 4 total. There's 2 battery pack connections, and then there's 2 motor connections. You want to make sure that there's no potential voltage difference between them before working on the vehicle to make sure it's safe. I also recommend that you get high voltage gloves. Safety gloves if you're working on any high voltage lines that are bright orange like this, just for safety. One other thing to note, that's a 12-volt system. The 12-volt system is completely isolated from the 200-volt system. I never knew what voltage I would end up on with my pack if I did build this vehicle out, so I did not get a DC to DC converter. So the 12-volt system is different, and it's charged separately. Here is the charge connection for the 12 volt system. It's just a battery tender connection. So any battery tender that you have for like an ICE vehicle, I used to use this on my Supra when I parked it for long periods of time. It should plug right in and charge that 12 volt battery. This is a relatively new battery. I think I got it last year. When I was driving the vehicle as a daily driver, I would have to charge this about once a week. If it's just sitting in my yard, I charge it about once every 3 to 4 weeks. So I know that you're going to strip this down, but it'd be nice to have a self-powered parts roller. So just make sure you keep an eye on that voltage and the meters in the cabin as you saw in the other video.